Hey everybody, my name is Jason, also known as Pirate JC, and welcome to part 3 of our 9-part video series that we're calling the Mystery Demo Tutorial Series. If you have not had a chance yet to check out the other videos in this series, please check the description down below, where you will also find the link to the previous state that we ended off with at the last video so you can follow along with this one. With this mystery demo series, what we're doing is we're building a demo together step by step, going in deep into each category and building something that you don't know about. You don't know what it is that we're building, but we're building up to something together. Hope you've enjoyed the ride so far. In this video, we're diving even deeper into waves. That's right, we started with a simple sine wave to move each vertex up and down based on a sine wave, and then we modified that sine wave to add horizontal movement to it with a Gerstner wave mathematical equation. Much more complicated, but that was video 2. And today what we're looking at is what happens when you combine multiple Gerstner waves together. So let's go ahead and jump over back to our GPU Gems Nvidia article about effective water simulation through physically based models. If we remember back, our equation number 9, our Gerstner wave equation, if we look closely, we actually see the symbol for sum here. And what this is saying is that any given final position at any point in time, x, y, and z coordinate for any given vertex is actually the result of the sum of multiple different wave equations together. And so really what we're saying is the final position is the result of adding and subtracting everything kind of together. So we're going to do that. Let's pick up right where we left off in our node material editor. Again, the link for this is down in the description below. And the first thing that I want to do is actually, it'd be great if we could kind of better visualize the Gerstner wave. You can kind of see the corner of it kind of moving a little bit, but it still kind of feels like it's just moving vertically. And that's because we don't have a good sense of the horizontal movement because we don't have anything on the surface of this. So let's actually add a texture node. So we're going to take a texture node, bring it in here. We'll kill off this color 4, and instead we'll connect the RGB value of the texture into the fragment output. And I want to add a checkerboard texture to this. So we have one available. You can find this URL down in the description below as well. playground.babylon.js.com/textures/amiga.jpg will do it. And I'm going to just copy this URL. And if we go back into the node material editor and click on the texture node, under source, we have embed static texture, and it allows you a button to upload your own texture. I'm actually going to turn that off, and we're offered to provide a link. And so I'm going to hit enter, and there we have our checkerboard pattern being rendered onto the mesh here, the moving mesh. And it's good, that's better that you can see it, but I'd like to increase the resolution here, and I'm going to do that by basically scaling up U and V. So I'm going to put the scale of U at 5 and the scale of V at 5, and that is a much better way to kind of see the squash and stretch and kind of movement as the wave vertically passes by. The X and Z kind of squash around it, and so you really get that kind of horizontal movement sensation from the wave, which is awesome, by the way. Love it, absolutely love it. Okay, next thing that we're going to do is we got to clean up this kind of hornet's nest that we made here. We're actually pretty happy with most of this equation. We've left ourselves some parameters to be able to change it. So we'll pull the parameters out, but the rest of this math we can kind of compress together to kind of visually forget about because we're basically done with it. Let's start by doing this. Let's dive in and grab these 4 nodes, the mesh position, the world matrix, the world position, and this vector splitter. Multi-selecting by holding down Control and then clicking and dragging. We'll zoom out and we'll just bring those way up here and kind of out of the way. And then the next thing that I want to do is let's pull out all of our parameters so they're kind of all visually in one place. So let's take wind direction, let's take wavelength, the other one that's here is speed. Again, these are all the things that we've sort of set aside that we may want to change later to kind of dial in the artistic look of how we want our waves to kind of react and look. And so that's our 5th one is steepness. Okay, now we've broken our frames that we had previously set up, our W, speed, and Q. It's not something that we're going to visit again. So basically, again, what we can do is we can kind of kill those off. It's not something that we need. So we're just basically doing this to effectively clean up. And then let's kind of zoom in here towards the end. We have, before we pipe into this vector merger node, we have two adds and a multiply in the middle. We're going to move that multiply over because we need these two add nodes to kind of separate outside of any given wave. And the reason for that is because if you look at this Gerstner wave equation back at the GPU gems page, you'll see that the addition to X and the addition to the original Z position, that happens after you add all of the waves together. So that's kind of the final step. So we want these two add nodes to exist. I'm just going to move those visually over here just so it's nice and organized visually for kind of how we're thinking about creating this. Okay, so that's looking pretty good. Now this kind of hornet's nest right here, basically all we want to do is just sort of squash it together. Again, it's not something that we're going to need to worry too much about or revisit. The math is pretty much dialed in. So we're just going to basically sort of squash this together and give ourselves a little bit more screen real estate. So just bear with me here. You can jump ahead as we kind of organize this if you don't want to do this. I will tell you this though, anytime you're working in a visual editor like this, it's always really, really good practice to keep yourself nice and visually organized. These tools are absolutely stunning and amazing and make workflows and creation super, super handy and easy. However, you can get yourself into a bad state if you ever create kind of a hornet's nest that you don't really understand or know how to deal with. So what I'm trying to get into the practice of here is basically, let's keep ourselves nice and organized all along the way. Now, we're not going to revisit this part here, so the fact that we don't understand the connections, can't see the splines as much, that's okay, because we're actually going to look at something, how to reduce this clutter visually here in a minute. Okay, so what we have now is effectively, this is kind of the equation of the Gerstner wave. These are the parameters here. We'll move these a little closer. And I want to think ahead before we start kind of duplicating this and multiplying it multiple times and then adding them together. Let's think ahead to how we're going to actually create this. We're going to create multiple waves. You want them each to have different directions, different parameters, maybe different heights and wavelengths and speed, different steepness. Each one's going to have its own unique parameters. And so to do this, as you combine multiples together, it's going to get harder and harder and harder to see the individual effects, especially the nuanced changes you make. So it would be really handy if we had a quick switch to be able to switch on and off any given Gerstner wave. Basically say, hey, don't evaluate this part of the tree and evaluate this part of the tree. So we're going to walk through how to do that very, very quickly. We actually have a previous video on this very subject. It's called the NME step node switches. I'm just going to move these over a little bit more. You can check that out. It's down in the description below as well. But a quick refresher on it. I won't dive deep into it here. We're going to grab a vector a vector merger node and a vector splitter node. We're going to need both. I'm bringing the vector splitter node closer to over here away from the wave. And we'll keep the vector merger node close by the wave. And essentially what we're going to do is take our X, Y, and Z and just pipe those directly into the vector merger node. And we're doing this to merge them together to create a vector 3. And we're doing this just for simplicity's sake down the road, which you'll see about in a second. Now, if I connect this directly up to here, and then I'm going to take my X into here, my Y is going to go directly across over to this vector merger node, and then Z is going to go down to here. It all works out totally fine. It all looks exactly as it did before, which is exactly what we'd expect. So what we're going to do is we're going to grab a step node. We're going to drag that out. Now a step node, quick refresher, it takes an edge value, and for this case, I'm going to call it 0.5, and I'm going to set it to a constant. And it takes an incoming value, and it says, hey, am I above or am I below this edge value? We'll turn this into a slider by setting the max to 1, and we're going to name it toggle. And what we're going to do is, anytime we toggle this, right now, the output of this, because 0 is below 0.5, the output of this will be 0. But if we toggle this up to 1, the output of this will be 1. So now what we basically want to do is multiply the values of X, Y, and Z by the output of this node. And to multiply across a vector 3, we have a node for that works, that's math standard. It's in the math standard section, excuse me, it's called scale. So what we can do is we can pass the vector 3 into the scale node and then connect this step node up to the factor. And then, so finally, what we'll do is we'll connect that into the vector splitter node. Now, you'll notice that the movement's going to stop. And the reason for that is because our toggle is set to 0. It's below our edge value of 0.5. Therefore, we're multiplying the values of x, y, z by 0, so there's no movement. If I move this up past 0.5, we get the movement back again because we're saying we do want them multiplied by 1, so we want their original values. So now we have a built-in toggle, which is super, super handy to turn on and off any given wave. Let's take the toggle and move that over to our parameters. That's the things we're going to want to adjust. And then we'll just take these 3 nodes here, and we will, again, just kind of move them in and collapse them in with the rest of this kind of cluster here. Okay, so now what we want to do is start to create multiple nodes. We'll start to do that by drawing a frame around this, and you can do that by holding down Shift on the keyboard and then clicking and dragging around your nodes. And then I'm going to do call this Gerstner Wave 1. We'll give that a green color. It's kind of a darkish green. And if you hit collapse, or if you double click on this top bar here, or if you hit this minus sign, all of them do the same thing, which is they collapse this node into one simple, easy node. So now that looks much more visually friendly. And what I want to do is actually copy this, select it, hit Control-C, and I want to copy it 5 more times. We're going to have 6 total waves here. So I'm going to say 1, 2, 3, 4, and 5. So now what we're going to do is just keep ourselves, again, visually organized. We will adjust each wave. We'll give it a new name. We'll give it a color. And then now we'll have individual parameters for those different waves, and they'll be visually really compelling and easy to see what's happening. So let's go to wave number 2. We will change its name to Gerstner Wave number 2. We will change it to, let's say, like a blue color would be good. And then we're going to go to our third one here. We'll call that Gerstner Wave 3. Maybe that one will be red. Looks good. We will check out this one. This is our Gerstner Wave number 4. And let's make this one like a yellowish kind of color. And then Gerstner Wave 5. And let's see, we're going to pick maybe a purplish color, let's say. And then finally 6, we'll change that to, I don't know, maybe a tealish color. Okay, so looks good. So now what we want to do is we have all 6 waves. This is good. We're actually going to toggle all of these off. So just so that we're not getting any effect whatsoever on them. And again, the thing that we can do here is we can individually toggle each one on when we're actually dialing in each individual wave and dialing in the parameters for each wave. And again, the reason I like to keep these off is just for simplicity's sake, so I know exactly what each wave is doing. And then after the fact, we can start to toggle them all on and kind of see the overall result. So let's just, almost done here, clicking these toggles off. And again, this is just a kind of a workflow preference. And last one, Gerstner Wave 6. Okay. So now what we need to do is we need to add these together. Let's get this yellow guy lined up, shall we? Okay. Let's add these together. So we're going to grab an add node, and we're going to need a total of 5 of these. So we're going to say Control-C, and we'll copy it 4 more times. Perfect. And basically what we're going to do is we're going to add the green and blue together, add the red and yellow together, add the purple and blue, which is waves 5 and 6 together. And then we're going to say, I want the sum of green and blue plus the sum of red and yellow, those will pipe into this one. And then finally, we'll combine that result with the sum of blue and purple. Okay, sweet. So let's just connect those really quick. We're just taking these vector 3s. Again, when we combine to that vector 3 earlier, we saved ourselves a lot of effort from having to actually put in 3 add nodes per wave combination. That would have been a lot more work. And so by doing it this way, we save ourselves a little bit of effort. So we're just adding those together, these together here. Oops. And then you basically get the idea that what we're doing is each individual wave adds together all of the values and gives us the end result. And so if we have different waves moving in different directions, that's totally okay. They'll either cancel each other out or add to each other in really fun and unique ways. And that's all something that we can dial in and have a ton of fun with. Okay, and the last thing I want to do here is I want to take the end of this add node and I want to pipe that over into the vector splitter node. Now, it is zeroed out again because we turned all of our toggles off, but look at how clean that is to create multiple Gerstner nodes. So now let's go in and the parameters, individual parameters that I'm going to use here, they're not important. I've just chosen some numbers that work to kind of give you a general idea. So I'm going to buzz through this fairly quickly. For this Gerstner Wave 1, I think I'm happy with these values. The only thing I'm going to change is the steepness factor. As you add multiple different numbers together, you'll notice that, we'll change this to about 0.19, that sounds good. You'll notice that the steepness can actually start to invert pretty quickly. And again, I mentioned this in a previous video, but you don't really ever want to go past 1. That's kind of perfectly vertical. And so you can do that if you don't have pretty small values with the more waves that you add. So I'm just going to go through here. Wave number 2, let's actually toggle this one on. So let's start to look at these. We'll toggle this on as we do this. So this is kind of what wave number 1 looked like. We basically had the same properties except for I think we had a 0.19, something like that for our steepness value. Somewhere in there. So it kind of looks something like that. But let's actually change this up a little bit. For wave 2, let's do an X value of 0.9 and a Y value of, or in our case, a Z value of negative 0.5. Yeah, that'll be good. So we're kind of changing direction here a little bit. Wavelength, we'll make this wavelength a little bit bigger. We'll call it 0.4, and the speed, we'll increase this one up to 1. And then our amplitude, let's make that 0.15, just a little bit bigger. And let's see, steepness, let's drop down just a little bit more. Let's kind of round that out just a little bit. Yeah, cool. Okay, and then we're going to toggle that off. And let's go into wave number 3. And again, we're doing this super in-depth, going step by step together to build out this mystery demo. Hope you're as excited to see what it's going to be as I am. So we'll call this 0.95. Yeah, let's tell it 0.95. And we'll do 0 in Z. Wavelength for this one we'll change to 2. Oh, actually, let's toggle it on so we can kind of see the difference, huh? That'll be fun. So this wave is going to be kind of a bigger wave. It's, yeah, we're going to make this one kind of bigger. It's going to have a bigger overall kind of slow roll kind of an effect over the whole entire world. To do that, since it's a bigger wave, we are going to increase the speed a little bit on it. And then the amplitude we'll set to 0.2. And then the steepness factor, we're going to bring that way down. We'll bring that to, yeah. So you kind of get this slow roll across the whole thing with this wave. Kind of like that. That'll just add a little bit of variety to it all. Okay, so we're going to turn that off, toggle that one off, and let's go into wave number 4. Okay, wave number 4 will have a wind direction of negative 0.35 and 1. We'll go 1 in the Z direction. Let's toggle that on so you can see what we're doing. There we go. Now you'll notice that we're starting to get that kind of pinch through that I was talking about at the very top, where we're kind of getting past 1. And that just kind of has to do with the parameters that we have here. So let's set the wavelength to 0.17. We'll set the speed to 0.6. We'll set the amplitude. Let's do the amplitude of 0.14. And then a steepness factor of kind of 0.15-ish. I'll really take that down quite a bit. Yeah, something like that looks decent. That'll be some nice choppiness to add in some turbulence into our wave. Okay, let's keep on going. I think we got 2 more here, so let's collapse that one, and we'll open up Gerstner Wave number 5. Toggle that on. And let's give it a wind direction. Let's give this like the opposite of Z. So let's do 0 and -1. And then a wavelength on that one of 0.5, a little bit bigger wavelength. We'll do a speed of 0.9, I think. Yeah, that looks pretty good. Amplitude can be a tiny bit bigger than that. Maybe 0.14 looks good. And then let's do a steepness factor of pretty low. We'll make this one nice and kind of roundish. Yeah, and that'll kind of work against the wave. So as the waves are kind of coming forward, it'll kind of push it back and push it up a little bit. So that'll be kind of fun. That looks pretty good. Okay, and then let's toggle that off. And now let's open up our last one. Almost done here with all of our parameters. Last one, toggle this on, and then we get to see the results of what we've made, which is super, super exciting. Okay, last one, we're gonna be the opposite of, we'll go the opposite direction of X, so we'll go -1 in X, and we'll do -0.95, just a little tiny bit Z. Now there you go, you can really see the effect that steepness factor can have with certain parameters where you go over that 1 threshold. So we'll dial that in as well. Okay, so for this one, we're gonna do a wavelength of 0.61 and a speed of 1.3. Make this one pretty fast, relatively speaking. And then let's do an amplitude of 0.2, take that up a bit. And our steepness value, will bring that on down to, yeah, about 0.15 maybe, something like that. Okay, sweet. So we've done all the values in there. Again, those values aren't super, super important. The whole purpose of this is just so that you can kind of start to see the results of all of this. So the last thing that we're going to do is we're just going to toggle all of our waves back on one at a time, and you can start to see the effect. There you go. There's multiple waves together. You can kind of see happening, starting to add together, and this is going to get pretty fun. Let's turn this one on. Let's see here. There we go. Definitely some more turbulence in that. And what we really want to do is try and get like a really kind of like choppy water kind of a look. Something that kind of feels like it would be, if you're looking at kind of a simulated liquid type thing. So that's starting to have some reverse effect there and work against it. So you got some kind of rise in some places. Very, very fun. Really liking that. And then these last two are really going to help kind of turn this into something super, super fun. There we go. Starting to really add a lot to this. Last one here. Boom. There you go. Something looks kind of like some super choppy kind of liquid, kind of a really choppy, turbulent surface of water maybe. And that is what it looks like to have multiple Gerstner waves combined together. And since we took the time to visually organize ourselves, actually visually not too complicated of a tree. Pretty awesome. I hope you've liked this so far. Multiple Gerstner waves together, super, super powerful. We're running at 60 frames a second here in Babylon with all of that math being combined and driving all of those X, Y, and Z values. I hope you've enjoyed this video and you're enjoying this series. If you have not had a chance yet to subscribe to this channel, we hope that you'd consider doing so that you don't miss any future updates. And thanks a lot for checking this out. We'll see you in the next one.